Hello and good day. So we are going to solve one of the problems in this code. Um, it's about um, the maximum points on the line. How are we able to determine among the points that are in Cartesian coordinates which line has the maximum number of points? It's one of the hard questions in the category of this code. The category is the hard one. So So what the question says is given an array of points where its I is equals to xi and yi, that's the coordinates of the points, represent the points on the xy plane. Return the maximum number of points that lie on the same straight line. So for example, here now we have points 1, 1, points 2, 2, and points 3, 3. You see that the three of them lie on the same line in this Cartesian coordinate. So the maximum number is 3. So if we have another example, example 2, now we have how many points here? 1, 2, 3, 4, 5, 6. There are 6 points. So we have 1, 1, 3, 2. We have 5, 3. We have 4, 1. We have 2, 3. And then 1, 4. So among the points that are here, the highest number of points are collinear. So that is the characteristics, the collinearity of points. The largest number is 4. They lie um, on the same line with the same coordinates. How are we going to determine if you have a several number of points on the same coordinates to find out the ones that lie in the same line? So how are we going to solve this problem? So the first idea we have to realize is that if they lie in the same line, in the Cartesian code, it means that they are collinear. It also means that um, their slope is the same. So, for example, the slope of from point 4 to point 3 is the change in x over change in y, which is x changes positively, y changes negatively in one degree. So, the y over the x is minus 1. So minus 1 of y and minus 1 of y of minus 1 of y and 1 of x. So minus 1 over 1, which is 1. It's the same differentiation, the same slope as of course maybe from 2 to 3, and then from 3, 3 and 4 for the same thing. So they have the same slope. So we are going to take one point and compare all the points related to that same point. And if they have the same slopes from that reference point, it means that they are collinear, it means that they lie in the same line. So that's how we're going to find that. And the question we now ask, if you now have slopes that are, for example, like I said, this one is like from point 4.33 is minus 1 over 1. What of 0.44? Say 0.441. So what I was saying actually, I made a mistake. It was actually 4132 and 2, 3, as in from xy. What I'm saying is here is xy is 1, 4, 2, 3, 3, 2, and then 4, 1. So the slope here is minus 1. But if you measure it from like 0.14 and then 2, 3, it's minus 1, 1. If you measure it from 0.14 and 0.41, the change in x is it's actually 3. So from one difference between 4 and 1 is 3. But the change in y is minus 3. So it's going to be minus 3 over 3. So we're going to have another function that will reduce all of them to a um, common slope. So it's not going to be like minus 1 over 1, minus 2 over 2, minus 2 over 3. All of them will be reduced to minus 1 over 1. So we're going to use the greatest common divisor, the function of the greatest common divisor, to be able to reduce all our slopes, to be able to now compare among of them which ones are similar, and then keep them in dictionary, in a hash table or in a dictionary. So let's see how we are going to do this. So I'm going to use VS Code for for that. So I'm going to use this to be able to solve that. So in this case now, what we have is, remember, the points that we have. So let me use the points in the second example. So let's use, so for example, these are the input points, and then the output is this. So we're going to get the maximum points. So the function I will use is the maximum points that we take in points. The whole idea is that if you put in this um, list of lists, that is going to give us the output of 4. So the first formula we're going to use in here is the formula of the get common divisor, the greatest common divisor, UD. So it's while B. So we have A, D is equals to B, and then A will do this. B, then return. No, no, no. Okay. I don't think it's going to. So if we have the GCD now, in this case now, so what I want to show in this formula here now is if you did the greatest common divisor. So if you have something like a total of 45 and a 15, let's think about this. So in this function now, so if you have 45 and 10, normally it's going to be the greatest common divisor of this is 15. So if you put it in this, our GCD here, GCD is going to give us 15, right? So if you try it with maybe say like a 9 and 3, the greatest common divisor in this is 3. So we're going to use this in our function. Then we create another function called slope, or let me call it get slope, that collects point 1 and then point 2, and then to calculate the slopes in 2 of them. So we say the y, which is going to be the change in y2, which is 0.21, and the change in y1, which is 0.11. And then the y6 is going to change in x2 minus change in x1. Now, if so, you have the y. If our the y is 0, it means 0 over the x is actually 0. So if the y is equals to 0, so it will return to us in string the value of 0. If our dx is equals to 0, it means the y over 0, which is infinite. So it's going to return infinite like this. Then we're going to get our divisor, which is GCD here, GCD dy and dx. And then we're going to so our divisor in this case, for example, if it is 45, 15, our divisor is 15, right? So we are going to see how we can reduce this thing to give us 3 and 1, which means it's going to be each of the numbers here has to be divided by the divisor, which is 45 divided by 15 and then 15 divided by 15, which will give us 3 and 1. So what we're going to do here is going to be whatever it is that I'm getting out, y over the x, it has to be divided by the divisor. And now the x has to be divided by the divisor. Something like this. So these are the two functions, yes. So well, remember, you said that we're going to use one point as a reference point for each of all those points. So if you have, for example, here, in, if we have this in this, our graph here. So if you are considering in points 4, 1, if we count the points that are collinear to this one, we see that it's going to be 1, 2, 3. But we need to also count this particular point. So it's going to be 3 plus 1 to give us 4. So at least for every of the maximum points that we have, at least one of it must be a point. There must be one point which is the reference point. Then we are going to count the other ones with. So in this case now, we are going to have this. It's taking time to show. So in this particular one, so we have the two functions gc and get slope. So that maximum point here will now come in here. So we have the maximum point, which is equals to 1. Then we continue for I in range of the length of the points. Then we have a collection of our slopes for each of the slopes, counting from the 6 points. Then for j in the range of the length of the points. Now this conditional statement checks if our I is not equal to j. So we don't want to have like a repetition of a slope with the same particular number. So for example, if you're considering 1 1 and you have 2 2 and have 3, you cannot have slope of 1 1 against 1 1. Which means it's going to be 0 over 0. So that's what it's going to out. If this particular point is not equal to its same value, the range of the points, then what we're going to do now is we're going to get a slope which is equal to get slope, which is points I and then points j. So for all the j, we are going to get this for now. You're going to get all the slopes in all the points that are not I. So now, if this slope is not in the main dictionary of the slopes, so you're going to create a dictionary and create the key for that slope. And you are setting 0 for now. And then we're going to increase it. Now, I think it is down here. So you're going to like, so if there's any value in the slope, which means that gathered number of the points for each of the points is each slopes. Then we're going to get the maximum points. We are comparing with the one we already have, which is 1. The maximum point is going to be the maximum of the maximum points, which in this case is 1, and then the maximum of all the slopes, the values that are in the slopes. whatever it is, then plus 1. Because 1 is taking care of points from which we are counting other ones. So it's going to return to us the maximum. Return to us the maximum points. I think it's done here. Okay. Oh, I think it's done. So if you check our points here, so we have here. These are our points. We're going to copy. It's supposed to give us 4. And then get what's the maximum points. Maximum points. And repeating this as our value. This gives us 4. So the term is correct. It's correct. It's correct. It's correct. So what we're going to do is that we're going to leave this function now and then put it here. We're going to leave this function and then put it in a equation here. We just simply copy it, right type it here. So we have get and it's going to be so. As long as we start time, we just leave it up and then just put it here since it's already working here. So we're going to put it here. The first function. Okay. Mm-hmm. Then the second one. So this is what it gets. This the y, the x, then we have this, and then this. If the x is equal to 0, we return this. These are the visual, then we return this. Then our maximum point is equal to 1. And then we just type this thing here. So for I in range length of points, slopes, collection for j in range length of points. If I is not equals to j, it got slope is equals to n. That's slope points I points j. If slope means slopes slopes slope is equals to 0, then slope increase it by 1, and then if slopes, we just copy this here to loops, get the maximum point. So get the maximum point. and I'm going to return this. So I think it will work easily. So let's test it and see whether it's going to, or if there's going to be any error. Okay. Points, yes. So we run this. There's an error somewhere. It gets slow. Oh, sorry, the mistake I was, I added semicolon at the end of this. So if you remove it here now, it's going to give us the answer we are supposed to get. So if you remove that, it's going to work out now. So if you're going to run it and see if it's going to work out now, I suppose it's going to work now. So yes, exactly. So it's accepted here. So in case one, you have it accepted, and then case two also accepts. So we are going to submit it. It's going to give us the value, is going to give us in the submission. So if we submit it, it's going to work out. Yes, it works out. So both the runs the runtime and the memory. It saves a lot of memory, was like 89.4% bits, 89.1%, and then the memory is was 11 MB, while the speed for the run is 82 MB. So this is just a brief example of how to be able to solve this question of maximum points on the line of a Cartesian coordinate.